Hello. Today we are going to continue chapter 6 about normal distribution. So let me briefly review what we have done so far. So first, in an earlier lecture, I have described the main difference between a continuous random variable and a discrete random variable. The key idea was that a continuous random variable has uncountably many possible outcomes, so we cannot define probability to a single outcome. Therefore, instead of considering probability for a single outcome, we have to consider probability defined by a cumulative probability. And from the cumulative probability, you may calculate probability of this form. So cumulative probability is a probability smaller than something. And then from this information, you can calculate the probability greater than something, which is not a cumulative probability, but it is implied by the cumulative probability. And also, you can also calculate probability between 2 points. So these three forms of probabilities are like just all we need. So any kind of probability can be calculated as a combination of those three types of probabilities. So that means a cumulative. If you know the cumulative probability, then you know everything about the whole probability. And then we also learned how to calculate percentiles or top alpha percent value. So they are just equivalent. They are equivalent, but looking from different angles. So given a probability, what is the value that satisfies a certain probability? And we learned how to calculate these when you have a standard normal distribution. So for a standard normal distribution, you need a standard normal distribution table or Excel or any standard normal distribution calculator. So it's not easy. It's impossible, nearly impossible to calculate a probability for a normal distribution because its functional form is very, very, very complicated. So you have to rely on something else like a calculator or a table. So we practiced how to do that. But what remains is non-standard normal distribution. So if your normal distribution, if you know that a random variable is normal, but it may not be standard. So if you have a non-standard normal distribution, we had to standardize the non-standard normal distribution. That's what we have done in the last lecture. This is the idea. So using these results, I have shown that when you transform x into y, I will deliberately transform x into a new random variable this way so that the new random variable follows a standard normal distribution. This is the standard normal distribution because the mean is 0 and the variance is 1. So this is the standard normal distribution. So that means for any non-standard normal distribution, you need to transform that non-standard distribution into a standard normal distribution, to apply the information about the standard normal distribution. That's what we are going to do. And it's simple. It is standardization, subtracting the mean, so it's recentering, and divide by the standard deviation, which is rescaling. So this standardization involves recentering and rescaling. So then you have a standard normal distribution. Then how can we use this transformation when you actually calculate the probability? Let me show you. Previously I gave you 4 different problems we are going to consider. First, 3 forms of probabilities: cumulative probability, smaller than something, greater than something, or between 2 points, and then finally percentile. So we are going to consider 4 problems of non-standard normal distribution. So let's start with this. So if you are interested in the cumulative probability of a non-standard normal distribution x smaller than a certain value a. So a is given, like say 100, whatever, any number, given number. Probability is smaller than a. Then how can you transform this into a standard normal distribution? We know x will be transformed into this form, and then this will be z. But what you have to be careful in here is that when you transform x, you have to transform the other side of the inequality. So to maintain the same inequality, you have to do the same transformation on both sides, right? So probability x smaller than a, you transform x, then you have to transform a in the same way. So I did it, we did it, and then the left-hand side of the inequality is the standard normal distribution. So I changed the notation into z. Then what you have to do here is a is a given number, and the mean and sigma should be like parameters. So then you can calculate that. If you know the parameters, then you can calculate the right hand side. And after you calculate the right hand side, you then need to use standard normal distribution table or Excel. We did exercise. We did some exercise how to calculate cumulative probability of a standard normal distribution on Excel. Remember, this is standard normal distribution, so you do not need you do not need to consider any non-standard normal distribution. Any non-standard normal distribution can fit into a standard normal distribution. So that's how we are going to use the standard normal distribution information. So here is this is the key idea. Don't forget. So many students forget to do this, but if you forget to do it on the other side of the inequality, then the inequality is not the same anymore. So the probability will be different. This inequality will be different. So don't forget to do the same thing on both sides. So I will give you an example. Say x is a random variable which measures the life of a tire in miles. So you choose a random tire of a car and or tire from a factory, and then record how many miles the tire can endure, right? Like in an experiment. So then obviously it will not be a standard normal distribution because the typical value of x will be maybe several thousand or even greater than that. So it cannot be the scale. The scale is quite different from the standard normal distribution. Standard normal distribution is around 0 and can take negative values and lies between, say, so 95% of the probability lies between plus minus 2. But 2 miles or minus 2 miles does not happen like 2x. So that is really unlikely for x. So we have to change. We are going to use different parameters. Suppose that the tire mileage, tire life follows a normal distribution, but I assume that the mean is 35,000 miles and sigma, the standard deviation, is 5,000 miles, right? So, by the way, I am using sigma, not sigma squared here. I use sigma because if you take sigma squared, then there will be 6 zeros, 3 more zeros. So there will be, like, the number will be much longer. So to keep the same unit, miles, I will use sigma instead of the variance. So anyhow, then it's simple. The mean is 35,000 miles and the standard deviation is 5,000 miles. And we would like to calculate the probability that a randomly chosen tire is worn out before 40,000 miles. So to interpret this, translate that, we are interested in this thing. Probability smaller than 40,000 miles. And then, okay, and then you know what we need to do. We have to standardize. We have to standardize that the random variable, non-standard random variable, into standard normal distribution, and then we will use table or calculator or Excel or whatever program you use. Let's do that. So the first step is standardization, which implies X will be transformed into this form. So this is the standardization, subtracting the mean and dividing by the standard deviation. But what you have to remember here is you need to do the same thing on the other side. So this is what you need to do on the other side, which is like this. And you know these values. First, the left-hand side, x minus mu over sigma, will be simply written as z because it is now standard normal distribution. So I will simplify this to z and plug in the values into mu and sigma. So mu is 35,000, sigma is 5,000. So you know how to calculate that. And then it is 1. So in the end, this probability equals probability of standard normal distribution smaller than 1. So you just need to find this probability from the table or from a calculator, which we did in the previous lecture. So, and the answer is 84.134%. So if you use the like Excel formula, then you are going to get this probability. This is this probability, the probability we are looking for. Okay, then I will ask you, this is an exercise for you. So same parameters, same situation. We are interested in probability that a tire wears out before 32,000 miles. So follow the same steps, standardization, and use a calculator or Excel or table, whatever you have. So and then find and then you will get the probability. Try this question, and then I will give you the answer in the next video. See you there.